All right, so we are talking about graphing relationships and situational graphing. Okay, so if the graph on the right shows the annual amount of rainfall during, oh, I suppose it's just one storm, what does segment D represent? So let's first think about how we measure rainfall. Does anybody know what we do to like actually measure rainfall? Allie, can you explain it to us? Yeah. When it rains, it fills up. Yeah, very good. So we've got like a graduated cylinder here. And then we put some measurements on the side here. And as it rains, the water level changes. Okay, so if we look at this graph and as time passes, I see segment D is right here, and segment D actually starts at 4 hours. This is saying what? What does segment D actually represent happening? Yeah, is the rainfall, remember we're measuring the rainfall here as a level in a glass. Okay, so if the level in the glass is consistent, what does that represent? It stopped raining. Okay, so the level of water in our graduated cylinder is no longer changing. Okay, so we would say segment D here actually represents the stop or end of the storm. And I could see why you would say that too, because if we were measuring like how much it's raining, we would say it's consistent here. But if we look at which segment represents the heaviest rainfall, which one would be the heaviest rainfall? What do you think, Travis?
Segment C because it's the steepest.
Yeah, very good. We would say C is the steepest. Steepest. Okay, it looks like we've got a decent grip on this. We'll kind of go through them rather quick. There are two words here, though, that I want to make sure end up in your notes, and that's continuous or discrete. And we'll kind of do some examples here to decide which is which. Discrete means incremental. Okay, so we can say incremental. Does anybody know what what does incremental mean? It's kind of a big, juicy word. Yes, I can. The number of pop cans collected for recycling.
What?
Constant?
Okay, that's not a bad example there. Well, let's think about it like this. Let's compare it to continuous. Continuous means we have all of the numbers. So this graph here is continuous because I don't just have 1 hour or 2 hour, but I've also got 1 1/4 hour or 1 1/2 hour or 1 2/3 hours. I've got all of the parts. So continuous means all of the parts. Discrete will be incremental in that it only moves by certain values. Only changes by a specific amount. Let me try and get in a little bit. And let's do some of these examples here to try and figure this out. When you take cans back, how many people have returned cans? Yep, some people probably have got like $30 worth because it's too crazy to get to the store right now.
My mom's like crazy about him. She goes there for work, trash cans, and like
Free money, free money. The number of cans collected for recycling. If you're collecting cans, can you collect half a can and still get paid for it? No, so this is going to be a discrete example.
Actually, it depends where you are. Because, like, Michigan is by the number of cans, and then Georgia is the weight.
That's interesting, actually. But if we were going to look at a graph of this, if I had maybe 1, 2, or 3, or 4 cans, we're getting big money here. We're getting maximum of 40 cents. This graph would be versus the number of cans. Number of cans. And it would go up like this. So this would be our money maybe. So the money we make only goes up in a dotted structure. But if you're pouring a glass of milk, is it a continuous flow of milk out of the gallon? Or do you pour, 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 pour? It's continuous. So we would call this a continuous function. Unless you don't know how to pour milk. The distance a car travels from a garage. Is that going to be, as we move away, is that going to look like this? Where we only hit 1 mile, 2 mile, 3 miles, and 4 miles?
They're leaving, so if they're on their way home, it would go down.
Well, tell me this, can you get 1 mile away without being half a mile away? At some point, so if we're measuring the number of miles and I want to get to a mile away, if you run 1 mile, at some point, are you going to have to ran half a mile? Yes. You will have to run half a mile at some point. So at some point on this function, or on this graph here, you will have to cross 1/2 mile. Or you would have to cross 1.5 miles. So this function is a continuous line. What about the number of people in a restaurant? Is that going to go up incrementally, step by step? Or is that going to just all of a sudden change from 5 people to 50 people? Well, does each person come in one at a time, or do they come in by halves? Can you have half a person enter a restaurant? No, so since I can't have the value in between the whole numbers, this is a discrete function. Suppose I missed an S here. This is all the numbers. All right, let's take a look at a couple more examples here. We're almost through it. Let's say that Jason, somebody named Jason, is taking a shower, but the drain in the shower is not working properly. Which of these graphs will match the amount of water in the tub? So we're graphing the water in a tub over time. It's important to know what we're talking about. So after 1 minute, it says there's 1 inch of water. What this graph would mean is that at the 1 minute mark, Jason turned on the shower and 1 inch of water just appeared in the bottom of the tub. Is that how showering works? No, that can't happen. It can't be A. C says, well, at 0, there was 3 inches of water in the tub already. Is that how showering works? No. So if we look at B a little bit closer, When we turn on the water in the bottom starts building. And then it keeps climbing because his drain is broken. And then it gets to here. What do we think happened at this maximum here? Good. He turned the water off and the level started going down. Okay. I think you guys have got a pretty good grip on this. Let's see if I can, let's find the domain and range of this. That's a good one to do. What is the domain? What values do we look at for domain? Antonio? The x values. So which x values can I have?
1 through 9.
Okay. Can we have less than 1? Yeah, so where should I start? Start at 0. So yeah, let's say then that my domain starts at 0. Can I have numbers like 0.5 or 0.6? Yeah, they're in between these numbers, right? So I'm going to say 0 is less than or equal to our x. And what's the maximum number it looks like I can have? Looks like I can get close to 8, but do I include 8? No. So I would say that my domain is less than 8. It's just our x values here. What is our range? Go ahead. Yeah, 0 to 2 maybe. Do I include 0 and 2? Sure, your guess is as good as mine. It looks like I should be able to say that I've got 0 water in the tub at some point. And I'll use y since our range is our y values. And let's say it's 0, but it's less than or equal to 2, because maybe at some point I get 2 inches. All right, let's double check and make sure I've gotten through everything that I wanted. Let's do one more example here. A bus travels at 25 miles per hour. It slows and stops to pick up riders. The bus picks up riders at 2 stops. Which graph matches this situation? Give me a 1, 2, or 3 by raising your hands. Which graph do you think represents it? Yeah, don't be looking at everybody else. All right, so I think we can safely concur that it's not C. And I'm going to underline one little section of this, and maybe this will help you out. A bus travels at 25 miles an hour. Does this ever travel at 25 miles an hour? It touches it, but it doesn't keep going. So think of it like this. If you were riding a bus and the bus driver sped up, hit 25 miles an hour, and then just let off the gas, and you slowly came back to a stop. Is that how the driving happens? Or do you speed up, get up to 25 miles an hour, go 25 miles an hour for a little bit, and then the bus driver hits the brakes? Probably A makes the most sense. Okay, because we're traveling at 25 miles an hour. So that means our speed is staying constant. Okay, can we ask any questions about this stuff? All right, remember the HRW, you can try the 3.1 HRW as much as you want before you start the SEQ. The SEQ is just an option to reduce your workload. I'll give you probably 15 minutes to get started, and then we'll talk about domain and range a little bit more.